Many engineers think that when a generator is offline, it does not need protection. After all, there is no excitation, no grid connection, and seemingly no risk, right? But that is not true. An offline generator can still be inadvertently energized, a condition also known as dead machine energization. And if that happens, serious damage can occur within seconds. To understand how serious this can be, consider one real incident. A 250 megawatt generator in a thermal plant was offline for scheduled maintenance. Its generator protection had been disabled, assuming it was not needed while the machine was offline. A switchyard commissioning engineer, thinking the generator was safely offline, decided to test the control circuit in an adjacent bay of a breaker-and-a-half scheme. During the test, a wiring mistake occurred. And because of that unseen error, the generator bay isolator and breaker closed unintentionally, energizing the machine. Within just a few milliseconds, the rotor surface temperature began to rise sharply. By the time the plant operator noticed what had happened, deep thermal cracks had formed in the rotor body, and the unit remained out of service for months. And this is not an isolated case. Generator damage due to inadvertent energization has been reported in many plants. In this video, we will understand how dead machine energization happens, what it does to the machine, and how to protect the generator against it. Let's start with how it happens. There are three main causes: operating errors, open breaker flashovers, and control circuit malfunctions. Sometimes, they even occur together. Operating errors are more common today because of breaker-and-a-half and ring bus configurations. These setups improve flexibility and reliability, but they also make switching more complex. With more breakers and more paths involved, a single operator mistake, or a control issue, can easily connect the grid back to the generator, causing inadvertent energization. In EHV breakers, high dielectric stress and small contact gaps can cause a flashover. Generators connected through low-voltage generator circuit breakers are also at risk. Accidental breaker closures, or flashovers due to loss of dielectric strength, have been reported in many plants. So, that is how inadvertent energization begins. Now, let's look at what actually takes place when dead machine energization occurs. The generator may be energized either on all three phases, or two-phase, or on just a single phase. In all cases, the stator becomes connected to the grid, and current begins to flow into the machine. If a three-phase voltage is suddenly applied to a stationary generator, it behaves like an induction motor. A rotating magnetic field is created at synchronous frequency, inducing heavy current through the rotor body and damper windings. The first effect, rapid surface heating in the rotor iron, especially around the wedges, retaining rings, and rotor body. If protection does not act quickly, this heating can lead to severe rotor damage. The stator, on the other hand, can usually withstand the short-duration current. But if rotor heating continues, rotor parts may break off, strike the stator, and cause serious mechanical damage, sometimes even total generator failure. If only one phase or two phases are energized, severe unbalanced currents flow, producing strong negative sequence components. These currents in the stator induce strong eddy currents in the rotor body, causing intense heating. This single or two-phase energization, often caused by open breaker flashovers, can damage the rotor within seconds. So clearly, the effects are severe. But you might ask, don't our normal generator protection relays detect this? Here is the reality. A typical generator protection system includes 5 elements that might detect inadvertent energization. Loss of field protection, reverse power, negative sequence over current, breaker failure, and system backup protection. However, their ability to detect dead machine energization is often limited. These relays are usually disabled when the generator is offline, as we saw in the incident earlier, or they operate too slowly to prevent serious damage. Because of these limitations, generator manufacturers and utilities now recommend a dedicated protection scheme designed specifically for inadvertent energization. We'll look at that protection in detail in the next video, including how it works and why it reacts fast enough to save the machine.